It's really a very nice feeling to be the president of a university of very many bright students. Every second year we have what's called a carnival, and the after party after the carnival, it's about 5,000 students present, and we are in one big room, and you know, the noise level when you get in there as a president is tremendous. I mean, they have a few beers and they're starting to chat, and then you just have to do shh, and in 10 seconds they are absolutely quiet. So it's much easier than with climate debates, I would say. So I would like to, I'm going to give the word to Bob in just a few seconds, but there were a lot of audience that wanted to make questions, comments, and so on. So let me check where you're sitting right now. 1, 2, 3, 4. So if I start 1, 2, 3, 4, 5, 6. So keep track of your number and then call me. So, please, Bob.
Thank you. I wish to respond to something you raised at the start of the last round of replies from the panel, and it was rephrasing somewhat. What is the opportunity cost, you asked,
yes,
of all the attention we are giving to possible human-caused global warming? In doing that, are we at risk of not doing something else or whatever? I think the answer to that is very definitely yes. And the reason I get most concerned about the, from my perspective, overdue attention to the possible problem of human-caused global warming is it takes away from the very real climate problem. There is a climate problem that we should worry about in the future. It was summarised well by Sten Bergström in his last but one slide, where he had a list of bullet points, and the penultimate point was words to the effect that the real problem is adaptation to the present climate. I could not agree more, and I would like to suggest, where is the gentleman, that he move that to the top of the list and leave out the other points, because that is the key issue. Future climate change is going to happen. We do not know, no matter what anybody tells you, and no matter how much greenhouse gas we pump into the atmosphere, whether that change will be up or down. If we look at the fossil record, it is very clear there are significant risks on a number of different timescales of dramatic cooling. And as Professor Singer has said earlier, if you'd like to live here when there's 6 degrees of cooling, well, you're welcome to it. Those coolings are firstly the start of the next ice age. Now, it's going to happen. The present interglacial has been going for 10,000 years. Many of you know the average length of time of interglacials for the last few 100,000 years has been 10,000 years precisely. However, there are arguments and there is a dispute which is not resolved amongst equally competent scientists, either that we are about, and by now I mean in the next few decades to hundreds of years, to go into the next glaciation. Alternatively, there are some good arguments that this particular interglacial might last for 20 or 30,000 years. Again, the point to emphasise that any reporters here is we do not know. The science is uncertain. So the first risk of cooling then is the next ice age. The next risk is several speakers have spoken about a 1,000 to 1,500 year long climatic cycle. And the previous peak on that to the late 20th century warm period was the medieval warm period. And prior to that, there was a Roman warm period. Now, those cycles are very regular, they're well established in the fossil record, and we're right now on the cusp of the turnover of the late 20th century warm period in those terms. Again, we cannot predict that it's next year the temperature is going to get cooler, but it may well, and I observe again that for the last 7 years, warming has actually ceased. So that's the second timescale where there's a risk of climate cooling. The third timescale, and again already referred to in this meeting, is the year 1816, known in Europe as the year without a summer, caused by the dramatic eruption of, was it Tambora volcano the previous year. In the recent record, in the historic record that is, there are similar years in the late 18th century of dramatic cooling of a couple of degrees without a known volcanic eruption. So we also have, and this is probably part of the natural variability in the climate system, the possibility of a sharp downturn on the scale of a year or two. So from my perspective, this is a time to apply the precautionary principle. And the precautionary principle says that there is at least a chance of at least as equal damage from a sharp cooling as there is from the present phase of global warming. Therefore, I encourage any of you that do not already own SUVs to please go out and buy one.
So Sten, you are satisfied being precautionary for the possible right reason, or? You don't seem to agree.
No, I don't agree at all. I think that you are completely wrong, and you are saying that there might be glaciation in the coming 100 years.
Give them the microphone.
Well, I think you are completely wrong, and you have obviously not been listening to the previous speakers. What we are seeing at the moment is that the climate is emerging above the noise of natural variability, as Hans von Storch has said many times. And this, we think, is to a large extent caused by global warming due to human influence. And I think there is loads of science supporting this statement. When it comes to glaciation, we are talking about timescales of tens of thousands of years. And I agree with you that on the 20 to 30,000 year timescale, we may be going into new glaciation, but that's not the issue. So I think you are mixing things up completely. As regards Sten Bergström, I also think that he gave a very good presentation. And it is, of course, true that we must also be aware of the present variation in climate and to avoid risks in connection with that, due to the way that society has developed, where we are living, where we're placing our houses, and so on and so forth. But on top of that, we have the risk of global warming due to man-made changes of atmospheric composition within the next few hundred years. And I think that is a serious risk, which we must look at. We can, of course, not say exactly when it will happen and how large it will be, but it is a risk for the future.
Could I put that question, if I take it a bit further? So what you're saying is, that there is weather, there is climate, and there is some sort of a pre-development, and all these are not connected in any easy way. Is that?
That we can have a change in the mean. I think one of the big research questions in climate science is, to what extent will that change in the mean also affect the variance? How may the variance of the system change in the future? And that's where we are now. That's where we have the big research questions, as I see it, and where we have to use climate models to be able to understand this better. Now, of course, the climate models also have to be based on the observations. It is a natural science. We are using observations both to construct our models, and we're using basic physical principles derived from physical laboratory experiments, which are the basis for the way we formulate the models.
Yeah. But sometimes you use the experimental data in a very unusual way, I must say, when I look at testing physical principles. But that we can. My more serious question is, what are your opinion and Sten's opinion when certain political stakeholders use the weather as the reasoning basis for long-term changes?
I think I react the same way as you do. I think it's anyone who is using just one event as the proof of that it's global warming. Of course, I react, because it's the only thing you can do. We cannot say that Gudrun, as I said many times now already today, it was not global warming, or at least it was not a confirmation of global warming. This has been abused, and that politician is an alarmist, of course. I can also say that I agree with Erland that we have this climate issue on top of a maybe more difficult problem with today's climate in many parts of the world. the climate issue had helped us focus on this problem as a whole. So it has been instrumental in solving other problems in society, and that is a good thing. So we are, I think, in a way we are doing the right thing in Stockholm for the wrong reason now. We are improving Slussen. It's necessary during today's climate. It will not be worse in the future climate, just for Stockholm.
Yeah, because my conclusion sometimes when I look at adaptation is that we can look at the changes in climate, in weather, I mean, in the short term, and think, but when we look at adaptation, we solve all the problems forever. I mean, there must be a time scale in adaptation also. Okay, now number one.
Thank you. The first point I was hoping to make was in fact a response to Professor von Storch, who's gone into his money-guzzling cab, but was that he suggested that there was no particular, it was purely academic, the argument whether global warming was anthropogenic or non-anthropogenic, and I just wanted to remind people that the argument that global warming is man-made has greatly influenced policies of organizations such as the World Bank and the IMF, who are responsible for lending money to poor countries to industrialize and build things like coal power plants. Now the World Bank and IMF, because of the success of this argument, will only lend money for schemes such as windmills and solar power plants. And these forms of electricity generation are not only very unreliable, they're also enormously expensive. This problem is not esoteric. We live in a world where a third of the world's population has no access to a reliable source of electricity, and as a result of that, according to the World Health Organization, between 4 and 5 million children under 5 die every year from respiratory diseases caused by breathing indoor smoke. And this is because their parents burn wood and cow dung in their huts, which I've had direct experience from. I suggest that if you're living in a hut like that and you have a child with respiratory problems, you have a different perspective of what the precautionary principle is. The second point I was hoping to ask, actually, was that for all the talk of economic stakeholders, few people have mentioned scientists themselves. It seems that there has, over the past 20 years, been an enormous increase in government-funded research in this area, much of which is based on the premise that man-made global warming is a serious problem. Is that a problem for science itself? I've heard it argued that in the pharmaceuticals industry, money can distort science. Is it true of this also?
You should do that.
Okay, thank you. No comment?
Well, I was asking Bob to comment, but I will. First of all, I'm glad we've touched back on science, so let me make a comment on the point raised by Källén, which is actually quite correct, and I agree with it. If I may restate it, I hope he'll forgive me, is that the natural fluctuations will average out on balance. They're chaotic. While the human input from carbon dioxide will grow with time, so that there is the possibility that the human signal may emerge from the noise. Am I quoting you somewhat correctly? Okay. This actually was attempted by the IPCC in their second report in 1995, and they published a learned discussion which claimed that the human signal has emerged, or was emerging from the random fluctuations of the climate, of the natural fluctuations of the climate. I will not take the time to reply to this here, but I do have a reply with me. Those of you who are interested in this, I'll be glad to give you a copy to show you that the attempt did not work. In principle, it could. In principle, it could and should, but it did not. It means that the human signal was much too small to be noticeable above the noise of the natural fluctuations. On the second point, just raised about the effect of money of funding on scientists, let me first of all say that I am not funded by government. So I have a fairly independent viewpoint on this. I'm not funded by industry either, and I'm just not funded, period. We receive donations from private individuals.
You're like this university.
Our group consists mostly of people who have their own means or are retired or on pensions and so on, and really don't depend on salaries. So we take a detached view on this, but it is a fact that a young scientist who wishes to advance in academia, in order to advance to a tenured position of, let's say, a professor, he has to publish research. To do research, you have to have funds. You cannot do much research without some support. In order to get funds, you have to write a proposal. In order to get your proposal approved, the proposal has to say that what you're trying to do is important. If you tell your funding agency that you're not going to come up with anything that is of any worldwide significance, you're unlikely to get funded. Furthermore, by now, the agencies themselves have an incentive to increase their budgets. And they do this by funding research that they can show to their superiors and to the Congress in the United States that what they're funding is of vital importance and deals with the, quote, risks, unquote, of global warming. So it's become a self-perpetuating type of activity, and it's not surprising that the amount of funding that now is available for pure scientific research, I'm not talking about technical activities, but is close to $2 billion a year. That is an unheard of amount of money, and in a sense shortchanges other fields of science and focuses a lot of attention of young investigators on this particular area, and they all tend to produce proposals that tend to stress the alarmist view of global warming. And that is a serious problem which we don't know how to deal with, and I suppose it's a serious problem everywhere because of the prevalence, the importance of government funding.
Okay, thank you. One short, very short.
Well, I must protest against this description of the way the funding system is working. I think it is much better than that. It's scientists who are sitting in these panels making evaluations of the proposals. And now it is, of course, so that the field of climate science does attract new young students because it is a fascinating field. And it is a field where there are huge amounts of problems to be solved. And there's no wonder that, of course, it attracts young people.
Okay, thank you. Number two. Yes, please.
Thank you very much, Mr. Chairman. My name is Hans Labohm. I'm coming from the Netherlands. I'm a climate skeptic. As a matter of fact, I'm a kind of informal spokesman of the climate skeptics in my country, which is a very surprising situation because I have no qualifications in the field. I have not done any physical studies. I'm just a simple economist who became interested in the financial and economic and political implications of the way how the climate issue has been dealt with. And of course I started as a true believer, and I started with reading the summary of Policymaker, and I have been a policymaker all my life. I have been the deputy head of the planning staff of the Ministry of Foreign Affairs in the Netherlands. And policy documents, well, that of course, that was a thing which I was very good at evaluating. And then reading the summary, I immediately came to the conclusion that the summary as such, the main message of the summary, was not in accordance with what I read in the papers. So there I saw a difference, a very important difference. I saw even in the summary, which has been criticized by many during this meeting, even in the summary, I saw a long list of uncertainties. And I think that as far as that is concerned, the summary is fair, although nobody seemed to bother about the uncertainties which have been explicitly listed, even in the summary. Now, I would like to come back to a few remarks which have been made. First of all, the previous speaker from the World Bank, I agree what he said. As a matter of fact, as an economist, global warming is only one challenge, and there are many other challenges. And a couple of years ago, it was Björn Lomborg in Sweden, in Denmark, who organized a meeting which produced the Copenhagen Consensus, in which a number of major international challenges were listed, their costs and their benefits. And the last priority was global warming. In terms of cost and benefits, was it actually a very poor proposal, because the costs of doing something, between inverted commas, on global warming were higher than the benefits. Hans van Storch said lack of agreement between the adherents of the global warming paradigm and the skeptics is not so relevant. We should work together on the follow-up steps. But I think it is relevant. If you think that it is not mainly man-made, then of course you are not thinking in terms of mitigation or Kyoto-like measures. If you are thinking that there is natural climate change, then adaptation, of course, is a necessary and useful step, but mitigation not. And it strikes me that here in this meeting, various speakers, even the adherents of the man-made global warming paradigm, were actually emphasizing the value of adaptation. And actually nobody came out as an advocate of Kyoto-like measures, which is very important. That means that there is a shift of opinion among the people who have thought about the problem. And it is paralleled by a similar shift in the Netherlands. Just a couple of weeks ago, a report by the Scientific Council of Government Research came out, which stated that the present climate policy in the Netherlands was wrong, and that it was that the measures which were effective were not politically feasible, and that the measures which were politically feasible, Kyoto-like measures, were not effective. Which is nice, but it was criticism of the government by one of the highest advisory bodies of the government of the present climate policy of the Netherlands. So instead, the Scientific Council of Government Research also advocated the adaptation measures. Now, the public is not willing to buy the message. That was a criticism, which is an observation here. Yeah, that is true, perhaps. But at the same time, our governments are spending lots of money. For the Netherlands, it's about 2 to 3 billion euro per year on all kinds of idiotic measures which have no effect.
Okay, could we? I must continue.
Yeah, and that is well, as you know, the European mini-Kyoto has been calculated by Wigley. The European mini-Kyoto, which we have now, will have a net cooling effect of 0.02 degrees Celsius in 2050, and it will cost something to the tune of 150 billion euro annually. This is a very interesting calculation, cost-benefit calculation, and I might have some reaction, some response to this calculation, whether it is true or not, whether people think, like me, that it is nonsense, or perhaps other
Okay,
response.
thank you. Number 3. Okay, then you'll be moved up. I don't know if it's an advantage or disadvantage, but...
Actually, I can...
And please, short, because there are many.
Yeah. I can understand the heated feelings about this, and I think, of course, it's a crucial question whether it's man-made global warming or natural. And I think Sten Bergström put the finger on the point when he said that you shouldn't buy ice cream from Germany, because that, as a private citizen, as a taxpayer, that is my question to the whole thing. Should I buy ice cream from Germany, or should I
use oil to build new dams. If I can't afford both of them, which should I do?
Okay. So, 5. Yeah, okay, sorry for I thought you gave up. Yeah, okay. So.
Tack. Ja, Björn Sohn heter jag presenterade mig inte igår. Jag är lekman här, kanske en av de få. Sorry. Yesterday, I forgot to introduce myself. My name is Björn Sohn, and I'm invited to come here. I'm one of the few laymen here, maybe the only one. And so first of all, I would like to thank you very much for the very interesting discussions and everything. A small comment. And the last speaker before the pause here, who has now disappeared, he mentioned that the scientists are doubtful about what they are doing. I live together with at least one person in this meeting today in the world of philately. And I can tell you honestly that there are similar attitudes towards groups when they are doing their so-called research and this and that. I don't think that the scientists are very doubtful about what they are doing. What I think, and we have seen that very clearly here at least, they certainly doubt what the other scientists are doing. And this is one of the points I wanted to make. Now the question. We had a visit here the other day of Al Gore, and his film is coming up in a few days, and there has been a lot of hoopla about all this. I would like to ask the panel, in what respect, when you take this film and the message, which, of course, from what we laymen would say, very, very, very important, any part of the world, how shall we actually look upon the message from this film in relation to what the various groups debating the climate and so on? That's what I would like to hear. Thank you.
Thank you. I'm going to give the panel the last word, so I'll pick it up. So we had 2 more. I won't allow any slides. Yeah, no. I mean, I give 2 minutes to each. That's it.
Well, no, I'll say things instead.
Yeah. Okay.
Where do I speak? Okay. You'll have to look at the... Sorry, you'll have to look at the presentation to see the OHPs, but I will refer to them. Thank you very much, Piers Corbyn from Weather Action, Long Range Forecasters. First thing I want to say is that I don't think we should get too upset about disagreement, because science has never advanced by sticking to consensus. In fact, it's only through breaking consensus that science has ever advanced. Furthermore, it's also true that no science has ever seen more than the first glimmer of the light of day, unless there's been some political, economic, religious or social force out there ready to support it. And because of the different forces out there that are for and against climate change ideology, we're in these arguments now. But in terms of the science, I want to put forward 2 challenges. Any climate theory has to explain 2 very basic fundamental facts about climate and weather as now. And we know some of these things from our long-range weather forecasts, which work very well, as you can see in the slides. The first most significant signal in all weather is, and especially world temperatures, is a 22-year signal. Now, to my mind, that can only be explained by particle magnetic effects from the sun, and any model has to include and understand that. The second thing is the very significant, very flat temperature curve which occurs during interglacials, like now, is very, very flat, compared with glacials, where there's massive variations. Now, in the interglaciers, there's not much ice around, so you should think that the buffering between water and ice would be much lower now. So we should have vast variations, but we do not have them at all. They've disappeared. So what is stopping them? And when you look at the paper I've got, you'll see an interesting idea, namely that plants are probably stopping them, because what we have is that plants transpire 100 times more water than they turn into sugar, and that is a cooling process. This cooling process is increased when there is more photosynthesis, which is increased when there's more carbon dioxide. And if you work it out, a doubling of CO2 can lead to a net cooling. A small one, but nevertheless a net cooling, including the photosynthesis feedback. Furthermore, if you halve the amount of CO2 because of nonlinear effects, you also get a cooling, a small cooling. So that means the plant system is going to regulate the interglacial temperatures to a maximum. And you can also explain some changes about in the Bronze Age and cooling from them by disappearance of Central African forests, appearance of Central African forests and disappearance of forests in North Africa. So those are the two challenges, I think, for science before us, and if we can crack those, then we'll know exactly where we're going with predicting even climate change. Thank you.
Okay, thank you. Okay, final? No? Okay, okay, so I give the word to Fred and Bob for final comments, and then I'll return the microphone and chairmanship. Okay, sorry. After the last one, then I return the chairmanship to Peter and Fred to come and take over. So, please. Yeah.
One issue that I've run into in trying to replicate climate studies, and I think it's one that sort of the official climate people should take notice of, is the difficulty in climate scientists archiving data and methods. There's an incredible resistance to doing so for reasons that I don't understand. The issues are important issues. All data and methods should be fully transparent, and yet eminent scientists like Phil Jones, in response to a request for the underlying station data, can make a statement like, we've been working at this, we have 25 years invested in this project. Why should we make our data available to you when your only purpose is to find something wrong with it? Doesn't, you know, if there's something wrong with it, then it should be found out. Now, that request wasn't made by me, but Hans von Storch became aware of this refusal and asked Jones to confirm that he said that, and Jones confirmed it. It's a silly issue for climate scientists to get involved in. You know, that it's pointless, the public won't accept it, and Michael Mann's gotten into this, Keith Briffett gets into it, Phil Jones gets into it. Other climate scientists should tell those people, you're just giving us a bad name, give these people whatever they want, you know, produce your data, archive your data, let the analysis go on unencumbered, and stop giving climate science, its other climate scientists, a bad name.
Thank you. So, please, Fred, you start.
Yep. Well, I guess Källén made the point, a valid point, that there's a lot of good science that needs to be done in the climate field. There are many examples. Let me give one. It's a pity that Henrik Svensmark is not here today, because he has an important message, and I did want to hear the latest about his current research. I will try to fill in for him in an imperfect way. You've heard about the effects of the sun on climate. In addition to the effects discussed by Willie Soon, which depend on the irradiance or the solar constant and its changes, there's a very important effect produced by the solar wind. The solar wind can affect the intensity of the galactic cosmic rays which impact on the Earth's upper atmosphere. The process has been studied by some, including me. It involves not a shielding of the cosmic rays, as many believe, but a deceleration, a loss of energy, as they are scattered by turbulent centers in the solar wind. Irrespective of the details, what happens is that you get fewer cosmic rays impacting on the Earth. Therefore, fewer cloud nuclei are created, therefore less cloudiness, and therefore more solar radiation reaching sea level. To sum up, high solar activity means, therefore, a warmer temperature, greater temperature. And lesser solar activity means more cloudiness and therefore lower temperatures. This effect is quite strong, very strong, but has been neglected, ignored by many people, except a small group, including people like Svensmark, Marsh, and a few others. Joanna Haig in England. Why is that? Well, it tends to overshadow other effects on climate, such as greenhouse gases. It is much larger. It's not mentioned in the IPCC report. It's mentioned, but it's not treated seriously. I treat it very seriously because the evidence suggests that the effect is quite large. And I will show just one slide, which I hope will convince you, as it convinced me, that the solar wind effect through cosmic rays is overwhelming on climate changes. And the evidence comes from many sources. I will show only one, from an observation of a stalagmite in a cave in Oman in Arabia. There are other caves where stalagmites have been observed and measured, and they show very similar results. But this is the original one, produced by Ulrich Neff. Can you get me back again? Thank you. I'm a guest. Okay. Produced by Ulrich Neff in Heidelberg. And let's see if I can find it quickly. I'll only show one slide. And what you will see is the effect of cosmic rays as measured by the isotope carbon-14, which is a direct indicator of the intensity of cosmic rays. And then you will see the effect of oxygen-18, which is a direct measurement, again, geologists assure us, of temperature, of climate. This is the slide. It covers a period of 4,000 years in the stalagmite. I don't think I need to blow it up. You see here the carbon-14, and you see here oxygen-18, and it goes from about 6,000 BP to 9,500, if I can read it correctly, almost 4,000 years. Notice the exact correspondence between carbon-14 and oxygen-18. This is the central section, which has been blown up and magnified, and there you see the correspondence almost exactly between carbon-14 and oxygen-18. These are independent measurements. One relates to cosmic rays, the other relates to temperature. These are large variations in temperature. They're natural fluctuations, not caused by man. This was done many thousands of years ago. These are produced by variations in the cosmic ray flux. You see here also, if you look closely, the 1500-year cycle that has been observed in ocean sediments, ice cores, and almost everywhere else by a geologist, and my colleague here can tell you much more about this than I can. And it evidently is caused by solar wind fluctuations. So the sun has an immense influence on climate, and very likely is responsible for much of the variability of climate that we've seen in the last century. That's really the only example I'd like to give, but there are many more.
I'd like to make two very brief comments.
Yeah, everyone should be short. Right, I think that's very important what you said, Fred, but bear in mind that the cosmic ray flux, or rather the carbon-14, is actually what the figures come from the changes in the solar wind. So if you look at the detail, the theory of cosmic rays should just give an 11-year cycle if you could resolve it all. But actually, there isn't an 11-year cycle, there's a 22-year cycle. So the main driver of climate change must actually be particles from the sun. And the observations that you might think imply that it's cosmic rays from outside, but it doesn't actually imply that. Thank you.
Thank you.
Two very brief comments to finish with. Whatever country you come from, you are used to hearing, either on television or on the radio or reading in the newspaper, that there is a consensus on human-caused climate change. Consensus is not a word that I like as a scientist. If there's one thing I hope that there is a consensus in this room about, it is that there is a consensus that there is no consensus on human-caused climate change. And I particularly make that comment if there's any reporters or documentary makers remained. I think it's an extremely important point. I have learned a huge amount during this meeting. I've benefited particularly from the trouble that Professor Stilbs took to ensure that some of the members of the community who strongly believe in the IPCC advice and the dangers of human-caused global warming are here. I should like to finish by thanking the President of the University, Peter Stilbs, Fred Goldberg, the ladies in the foyer, and doubtless many helpers that I don't directly know about, on behalf of all of us, and especially the invited speakers who have been treated in a privileged fashion. And Fred and I are very well aware of the privilege it is for us to be sitting here, in a sense, having more time for our views than the people in the audience. So thank you very much indeed, gentlemen.
Well, thank you all for coming here, and I want to thank all the speakers also for all their efforts. And I think this meeting had its ups and downs, but in general I think it was quite successful. I particularly like to thank Fred Goldberg, who has done an enormous job in all the practicalities. And also his wife and her friends that were in the secretariat also did an enormous job. And some people have asked if there will be any additional information. Most of the lectures that you saw were updated versions of what you find on the CD, and some of the lectures were actually not received in time for the deadline for the burning of the CD, which was last Friday. We don't really know how to proceed. We had some plans to put everything on the internet in PDF form or something, but some people think there may be problems with copyright and stuff like that. So we will probably not do that. But on the web page you will find some information about what will happen. We haven't decided that yet. So thank you all. just det. Jag vet aldrig.
Kör hela rasket rakt av bara.
Ja, just det. Jag kan lägga in mina intros där.